Solving one-step inequality, part 2. In this one, we're going to talk about what happens when you divide by, multiply or divide by a negative number. What happens to an inequality sign? So Tammy Parent limited the number of text messages she is allowed to send each month to at most 100. That means 100 is the top part. I mean, she cannot send any more than 100. It stops at this ceiling. So far this month, Tammy has sent 64 messages. Write an inequality can be used to find M, the number of messages Tammy could send for the remainder of the month. So Tammy already has sent 64 messages. She can send some more, but it cannot be higher. So it has to be less than or equal to 100. Because at most, 100 is where it stops at. So she can send all these messages, but it has to stop at 100. Because I'll be honest, I almost got confused too. I did it this way. And I realized to myself, if I had done it this way, that's at least. That means she can send higher than 100. That means her parents were telling her, I want you to send more than 100. Because you need to get more friends. So this one is at most. So here is our inequality. 64 plus M is less than or equal to 100 at most. This is up what she can do. So for each of the following, indicate whether the value is a reasonable solution to the inequality for the situation by writing yes or no. If she sent 40 text messages, we're plugging in. 64 plus 40 is 104. Is that less than or equal to 100? I don't think so. You know what? Instead of me flipping back and forth, I'm going to rewrite it. 64 plus M is less than or equal to 100. If I put in negative 3, that means I'm not sure how you can have negative 3 text messages. So if you plug in 64 plus negative 3 is 61. Is that less than or equal to 100? It is. If I plug in 30, 64 plus 30 is 94. That's less than or equal to 100. If I plug in 35.5, I don't know how you can send half of a text message. That's 99.5. That is less than 100 or equal to 100. If you plug in 36 to this, that would be 64 plus 36 is 100. That's less than or equal to 100. So all these are examples of things. The only one that did not match was 40. So now solve this inequality. So the inequality we get was 64 plus M is less than or equal to 100. So we have to solve it. All right. I need to keep M, the variable, by itself. What operation, or what is the inverse or opposite of 64? Minus or negative 64. It's the same thing. So this canceled out. Again, in the balance scale, if you take 64 away from the left side, you better take 64 on the right side. If not, it's going to get lopsided. So 100 take away 64 is 36. So M is less than or equal to 36. So 36. What are two integers to the right of 36? 37 and 38. What are two integers to the left of 36? 34 and 35. So are we including 36? It is a closed dot. She can make 36 text messages. It should still be okay. But what numbers are less than 36? 35 is less than 36. 34 is less than 36. And so do you see how this arrow is facing the direction to the left? So again, let's go back here. As you can tell, all these numbers are less than 36. That's why they were all yeses, 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 yeses. So again, how do you solve an inequality? You have to it's like solving an equation. You have to have the variable on the left side, and the numbers on the right side. But we must also pay attention to the direction of inequality. There are things we can do without affecting the direction of inequality. When you add or subtract, or multiply or divide by a positive number, the inequality stays the same. If it's facing to the left or facing the right, you leave it alone. However, this is where it gets tricky. This is true high school stuff, but now it's 6th grade now. But these things will change the direction of the inequality. For example, if it was less than, it will become greater than. It flip-flop. When you multiply or divide both sides by a negative number, when you multiply by a negative number, the sign will flip-flop, flip-flop. For example, if it was This one, if it was greater than or equal to, it will flip-flop to less than or equal to. If it was less than, it will flip-flop to greater than. So you might say, but why? Well, let's see why. Negative 3 times a number is less than or equal to 9. So negative 3 times negative 5, remember, when you multiply or divide is an easy thought. Same signs are positive, different signs are not. So when you multiply by two negative, number is positive. So that'd be positive 15. Positive 15 is not less than or equal to 9. False. Negative 3 times negative 4 is positive 12. That is not false. Negative 3 times negative 3 is 9. Is 9 less than or equal to 9? True. Negative 3 times negative 2 is 6. Is 6 less than or equal to 9? It is true. And I think the rest is all going to be true. Like negative 3 times 5 is negative 15, which is less than or equal to 9. True, 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 true. So going to my number line, I will circle negative 3 is true. Negative 2 is true. Negative 1, 0, 1, 2, 3, 4, 5. All these instances are true. So let's solve this equation now. So the equation was negative 3x is less than or equal to 9. I need to keep this variable x by itself. What operation is the inverse of negative 3? Dividing. So I divide this by negative 3. I divide this by negative 3. So negative 3 divided by negative 3 cancels out. That becomes x. 9 divided by negative 3 is negative 3. And now, this is where it gets confusing. When you are dividing or multiplying by a negative number, this line flip-flop. So this less than or equal to will be flip-flop to greater than or equal to. Let's look at our example, our number line, see if this is true. So I go to negative 3. Close dot, because I'm including it. What numbers are greater than or equal to negative 3? Negative 2 is greater than or equal to negative 3. 2 is greater than negative 3. Do you see how all of it is facing now to the right-hand side? See, if you look at this, in the original problem, the direction was facing to the left. But as we did this with examples, plugging in, it all started facing to the right. So when you multiply and divide, it flip-flops. So multiply and divide by a negative number, it will flip-flop. Let's try another example, see if this really is true, or Mr. Joe is full of hot air. Negative 2 times negative 5. That will be positive 10. 10 is definitely greater than negative 6. Negative 2 times negative 4 is positive 8, greater. Negative 2 times negative 3 is 6, greater. Negative 2 times negative 2 is 4, greater. And greater, greater. Negative 2 times 1 is negative 2, greater. Negative 2 times 2 is negative 2 times 2 is negative 4. That is still greater. Negative 2 times 3 is negative 6. Is negative 6 greater than negative 6? No, it's the same thing, so it's false. Negative 2 times 4 is negative 8. 8 negatives, which is so far away from 0, is definitely not larger than negative 6. So all these are false. Look at your number line C. So let's circle all these numbers that make it true. Negative 5, negative 4, it goes all the way to 2. All these instances are true. Let's look at everything. Our question is this, negative 2y, negative 6. So as you can see, if original problem, it says it should be facing to the right. That's weird. This is facing to the left this time. I wonder if we're going to be multiplying or dividing by a negative number to flip-flop it. I need to keep this variable by itself. What operation is the inverse of multiply? Dividing. So I divide this by negative 2. I divide this by negative 2. Negative 2 divided by negative 2 is 1 whole. It cancels out. Negative 6 divided by negative 2 is 3. Y is greater than 3. So let's go to 3. Open dot, because you're not including 3. Oh, I almost messed up right here. Because I was thinking to myself, what numbers are greater than 3, 4, and 5? But there's nothing here there's nothing here. Plus, if you look up here, it says shade to the right. Here's every shade that. I almost forgot myself. When you multiply or divide by a negative number, you have to flip-flop it. Flip-flop. So this is the answer. What numbers are less than 3? 2, 1, 0. So it faces to the left. It is faced to the left. Look at this arrow. Do you see how it's faced up? And we proved it by substituting the variable with these numbers. So let's go through each question now and practice this. So C plus 6 is less than 15. Again, what operation is the inverse of plus 6? Minus 6, minus 6. 15 minus 6 is 9. C is less than 9. So we have 9, 10, 11, 8, and 7. Open circle. C is less than 9. So what numbers are less than 9? Is 8 less than 9? 7 is less than 9? It is. This one goes here this way. Again, to check your work, plug it in. 7 plus 6 is 13, which is less than 15. Plug it in. 8 plus 6 is 14, which is less than 15. Plug it in. That's why it's facing to the left, and it's left of 9. Next one. B take away 9 is greater than 2. What operation is the inverse of minus 9 plus 9 plus 9? Cancel. So it's B is greater than 11. So you have 11, 12, 13, 10, and 9. Open circle for 11 because we're not including 11. What numbers are greater than 11, 12, and 13? So it faces to the right. Let's plug it in. 12 plus 9. 12 minus 9 is 3. That's greater than 2. 13 minus 9 is 4. And that's greater than 2. That's why it's facing to the right. Next one. What operation is the inverse of multiply? Divide. So we're dividing by 4. Dividing by 4. So T is less than or equal to 4. So we have 4, 5, 6, 3, and 2. We're closed up because we are including 4. What numbers are less than 4? 2 and 3 are less than 4. It's facing to the left. And let's plug it in. If I plug in 4 groups of 2 is 8. Is 8 less than or equal to 16? It is. Plug it in. 4 groups of 3 is 12. Is 12 less than or equal to 16? It is. Next one. Multiply by 3. Multiply by 3. That's the inverse operation. So as H is greater than or equal to 12. So we have 12, 13, 14, 11, and 10. So what numbers are greater than or equal to 12? Closed up because they're including it. It's 13 and 14. Let's plug in and see if this really works. If you plug in, let's do 15. Is 15 divided by 3 is 5. Is 5 going to be greater than equal to 4? It is. That's why it's facing to the right. Now let's try some of the harder one. This one, we're dividing by negative 8, dividing by negative 8. So it's T, 16 divided by negative 8 is negative 2. Let's see, I divided by a negative number. So I need a flip-flop our inequality sign. So it's negative 2, negative 1, 0. That'd be negative 3, negative 4. So negative 2 is a closed dot because it's equal to. What numbers are greater than or equal to negative 2? 0 is greater than negative 2. Negative 1 is greater. So it faces to the right. But this is the big test. Why are we flipping that inequality sign? If you plug it in, if I plug in 0, is 0, negative 8 times 0 is 0. Is 0 less than or equal to 16? It is. If I had not flip-flopped that sign, I would have said like negative 4. Negative 8 times negative 4 is positive 32. Can 32 be less than or equal to 16? No. That's why you have to face to the right. Next one. What is the inverse operation of divide by 3? Multiply by 3, multiply by 3. So it's n, and this is negative 3. 12. All right, this is a trick question. I am multiplying by 3. Is this a flip-flop? Are we flip-flopping the inequality? No, we are not. Because you only flip out when you're multiplying or dividing by a negative number. So we have negative 12 in the center. Then we have negative 11, negative 10, and negative 13, and negative 14. So negative 12 we closed out. We are including negative 12 as part of the answer. So in which instant will it be greater than negative 12? What happens if you're getting confused because you don't like negative? Let's do positive. Will 1 be greater than or equal to negative 12? It is, so it has to face the right. Also, look at the arrow. It's facing the right. Let's plug in it. Let's see when this is true. If I put in 12, 12 divided by 3 is 4. Will 4 be greater than negative 4? Yes. If I plug in negative 9, is negative 9 divided by 3 is negative 3? Is that greater than or equal to negative 4? It is. All right, so here's our last question. Here's a word problem. Nancy needs no more than 35 beads to make a friendship bracelet. No more than. That means 35 is the ceiling. It has to be less than 35. Cannot, no more. 35 is stop. That is the most. At most. That's just, actually not even at most. It's just that's the most it can be. 35. You have to stop at 35. To make a friendship bead. She already has 12 beads. Write an inequality to find B, the number of beads Nancy could use to find a bracelet. So she already has 35 beads. If she adds more beads to it, I'm sorry, stop. Nancy already has 12 beads. She adds more beads to it, then she'll have 35. But it cannot be more than 35. At most, 12 plus B is less than or no more than 35. So it has to be less than 35. So we need to solve this inequality now. What operation is the inverse of positive 12? Negative 12, negative 12. This cancels. 35 with 12 negatives is 23. So we'll plug it in, 23, 24, 25. 22, 21. Is this an open dot or closed dot? Is it an open dot at 23? It has to be numbers that are less than 23, which are 22, 21. It's facing this way. So if she made 22 bracelets or 21 bracelets or 20 bracelets, she'll be okay because it's always going to be less than or no more than 35. So the main thing I want to talk about this one is if you are dividing or multiplying by a negative number, you will have to flip-flop the sign. For example, if you had negative 4x is less than 10, and you want to divide this by negative 4, divide this by negative 4, you'll get x, and this will be negative 40. You flip-flop the sign where every number that are greater than negative 4, if you plug this back in, will be less than 10. And so on. All right.